Alright. Welcome. It's another exciting day. Comp. One. Two. No, not one. 229. And what we're going to be doing today is just going over some chapters. Again, that's pretty much what the lecture is going to be devoted to. I'll end up putting some assignments in for you all to start completing for the next week or so. So those will kind of just be placed in the canvas. And then again, please make sure that you end up asking me questions. And just so that you all are aware, just a couple of other things that are going to be coming up, right? At the end of the semester, we're definitely going to end up doing at least one more coding interview type of thing, just like we had before. That initial coding interview that you had at the beginning of the semester, we're going to do that again at the end of the semester. So just to kind of see, again, so that way you all can start measuring kind of the progress that you all have ended up making, which is great, right? So we'll have that as well as a couple of just additional side activities. But really, you working on this project is going to be where you're going to be devoting most of your resources to. We have a couple of lectures, but that is going to be the bulk of what you should be doing over this last month. We just have, I think, maybe even a little bit less than a month left. So that's really where you're going to be putting most of your time and devotion. You want to think of that open source project or, the algo game, whatever the large scale project, that is your final project, right? And so I'm going to be giving you some guidelines for things that I would like you to start doing, as well as, having a little bit more interaction with you all as well. So please make sure that you end up keeping that in mind. Be on the lookout for me. If you're waiting on something, please send me a message. But with that, let's go ahead and just get started for today. So we're going to be talking, like I said, about chapters 21 and 22. The first chapter really being about dependencies and then the other one being about large-scale changes. But that's really kind of our agenda for today, is really to kind of just talk about dependency management and large-scale changes, which both end up being from the Flamingo book. And so we're just going to, get right into it and just start talking about that first chapter, which is going to be, chapter 21, which is dependency management. So one thing that you may end up thinking about is one question that you all may consider is just what is a dependency, right? What is that? And I would just say that's pretty much just a library, a package, or just some other type of external dependency that we don't control. So if I was to strictly think about this from a theoretical standpoint, if we take the idea of you all working on algo game, right? Unity could be considered a dependency. In a theoretical sense, we're not going to mostly talk about that. We're going to mostly be talking about libraries and stuff. But I would end up saying, hey, Unity's something that we depend on that's outside of our control. If something happens to Unity, we're kind of hoping that ends up working. But if something happens to Unity, or if Unity decides to make a change, to any type of thing, right? Whether it's code or whether it's their licensing structure, then we're affected by that, right? And so, that's something that would end up happening. Similarly, I think even, some of the JetBrains products, right? Writer, you could rely on Writer as your IDE, so you could even say Writer is a dependency. And again, that's mostly from, this very academic version of this, right? That both of those are tools that are external, that are just external that we don't necessarily have control over. Okay. For the purposes of what I'm going to be talking about mostly with you all today, though, is not necessarily those types of dependencies. It really is going to be like libraries and packages that we normally end up depending on. And so for those of you that were in 55, right, using the ACM library was a dependency that we ended up using. Some of you have heard of Boost, right, or things like Flask, Django, right, from Python. Spring, right? Those end up being dependencies, right? They're libraries, but again, we're not controlling those libraries, we're not controlling those libraries, and so then we depend on them, and that's what ends up kind of creating that issue. Okay, and so when we start kind of collecting all these libraries and dependencies and stuff, then we have to start thinking about the idea of dependency management, which ends up bringing up a lot of different questions that we have to think about, right? So, dependency management, just before I actually get into all these questions here, really it's really just the management of all of these, networks, libraries, packages, and, dependencies that we don't end up controlling, right? So we have to be able to figure out how to be able to do that. They also ended up saying that it's one of the least understood in the book. They said it was one of the least understood and most challenging problems in software engineering. And so I want to kind of talk to you about, why something like that would end up being. So let's kind of just think about some of these questions, right? That we would have to think that, we need to consider, right? If we are going to end up doing something about dependency management, which is like, how do we end up updating between, versions of external dependencies, right? How do we even describe versions at all? How do we know when to use a dependency? And, how do we control the development of a dependency or sub-project, right? Those are all sort of different things that we have to deal with the dependency management. And normally, again, if we were to think about sort of like this idea of like, okay, why is this really so hard? We're not necessarily just talking about having a single library here, right? We're thinking about having a network of these libraries that we then have to manage over time. And that over time part ends up making it tricky. And again, makes us have to think about these questions that we have here, when it comes to the idea of not necessarily doing something from a programming standpoint, but doing something from a software engineering standpoint, right? Updating versions, so updating between versions kind of makes dependency management tricky. And then we have to think about the versions part, and again, when we would want to use a dependency versus perhaps rolling our own, and how we end up being able to control that development. Yeah, because that's a big question that we end up having. And so again, thinking about this, right, the idea of dependencies, I just want to reiterate, right, like, it is this library. We're not necessarily just talking about one library, though, in a lot of these situations. A lot of those very popular packages and libraries that you all end up having, right? Even if you were to just say, well, I'm just going to use one library, or, oh, I only have one library that I'm using. If it's a popular library that's out there, most likely that library is actually built on top of other libraries that it ends up depending on. And so from that standpoint, there's this kind of like large network that ends up happening with any dependency that you would end up having. Let me go ahead and just show you an example of this, which would end up being from React, right? The Create React app. I'm going to just go ahead and show you the dependency graph, which is just like, here's all the libraries that Create React depends on, okay? So Create React app is here, right? And you could see that it ends up, depending on all of these, particular things, right? As soon as you kind of say, I'm going to import Create React app or kind of use that, it uses all these. And then you could start to see again that some of these end up having, other libraries that it ends up depending on. But then in other cases, and here we kind of nicely just stop, but there's these other situations where we have these other dependencies, for example, this one here and this one here, that both actually end up using, as well as this one over here, both end up, all end up using this particular, library that's over here, right? And so it is because we need to manage just this network of dependencies that are really all changing over time. That really makes, this idea of dependency management so hard. And this isn't just Create React app, right? There's a lot of the popular frameworks that you have out there. This is actually from a site called npmgraphjs.org, and let me just let's show it real quick. npmgraphjs.org. I'll go ahead and just put it in here, and then kind of move that over here. Perfect. Okay, so here was just it's just a way for you to be able to do anything for Java projects in particular, right? So with Create React app, which again isn't necessarily React, but it just is a way for us to be able to easily start React scripts, you can end up seeing that we have that same type of graph that we have here. There's other things like Express, right? Express is another type of JavaScript framework that ends up being used a lot, and you can see that it has a lot of kind of top level domains, but it has also these very interesting things, and even something like so you can kind of see that it's there's a lot of kind of libraries that it ends up depending on at a very top level. And then there's also things like Vue as well, right? Where we could say something like Vue.js, where we could do something like that, and we should be able to see it. Hopefully, you could see again. It's a lot, right? There's a lot of stuff kind of going on, in terms of all the different sort of things, and we have some interesting stuff kind of going on back here, right? So again, very kind of interesting in terms of being able to think about, when we have different dependencies, right? That we normally just think like we're like, oh, we're just going to use this one library, right? And we end up thinking that that's it. But then really what ends up happening is that that library ends up using a bunch of other libraries, and that chain kind of continues until it doesn't, right? But it ends up being a lot of these, and some of them have these different kind of paths to be able to go through and to use different paths to be able to do this stuff. And that actually ends up becoming really cumbersome for us, right? Because we start to have these dependencies that depend on other things, and we have this kind of network of libraries. There's a lot of stories out there about just certain issues that end up popping up. So for example, take a look at this comic here. Here we have something where it's just like, just this comic where it says, I heard you need to create a TPS report. Here I've got an R script that does it already. And then, then they say, why does it keep dying? And it's like, oh, it's because you need to download these 5 packages first. And then I did it. And then it's like, well, it worked 3 weeks ago. And then it's just like grr package updates. Okay. So this ends up happening kind of a lot. Okay. And, there's these things about these packages and this, again, these versions updating and stuff. And why is it that the versions end up being such an issue? And that's really due to this idea of what's called the diamond dependency problem, which I'm kind of showing you here. Okay, so imagine that this is library A. I'm just going to end up saying that here. Library A is going to end up downloading packages from library B and library C. Okay, and library B and library C are using library D. However, library B ended up using version 1 of the library D package, and library C ended up using version 2. Okay? In some languages, right, if you have something like library A and then it ends up wanting to use something in library D, it's like, well, which one of these two versions is it going to end up using, right? And so this ends up becoming a little bit trickier for us to be able to solve. But there are different ways of this solving it. Like, so for example, sometimes what ends up happening is that, library B, if it's using version 1, it may end up renaming functions, right? You can end up renaming the functions from library D, and you can end up renaming the functions from library C, from library D in version 2. You would be able to rename the functions for each of these, and this could end up working. But then if there's like types or something, then that also becomes more of a struggle here. So you have to kind of just be aware that, many times there's that this ends up causing a lot of problems. And so the way that this ends up being solved sometimes is, if they want to kind of have a version. I mean, there's other things that sometimes the languages do, like they'll kind of place these dependencies into like their own subfiles or subdirectories, right? And kind of like almost in a way shade it so that, library B only ever sees library D's version of it, and so on and so forth. But another thing that they end up doing that I think is more common is just that there ends up being a manager, like a dependency manager, that tries to look for a common version, right? That maybe looks for a common version, like saying like, oh, maybe 1.5 or something, or some other version that's like, 2RC or whatever it is, right? Some other version that's not version 1 or version 2, maybe even let's say version 3. That we have version 3. And the dependency manager is just going to end up looking for different versions to try and look for something that is compatible with both of these libraries, right? That both of these would end up using this thing. But if you think about it, this idea of the diamond dependency, it's really hard for us to be able to figure out, right? Because if you think about it, if we have library B and library C, like they may not necessarily know anything about each other, right? Like, those two libraries can be something that's completely separate from one another, right? Like, for example, one could be a library about a logging framework, right? For example, like log4j or something like that. And then the other library can be, something about, like, let's say a Twitter API or something, right? Where it's like, how would the Twitter API know anything about log4j, right? Or you could throw some type of graphics library in there, like LWGWL, right? Lightweight graphics Java library, whatever that one. How is that going to know anything about log4j? Like, why would those two things ever kind of combine together? Or the Twitter one with the graphics, right? It's so hard for you to be able to say, oh, we all need to kind of be standardized. And so that ends up becoming a hard problem, because if you have kind of one library over here that's using, a particular function, and then like, I guess we could even take it like, for example, with Log4j, right? That the Twitter API uses Log4j, and the graphics library uses Log4j. How is someone else going to ever know that the Twitter API is going to then combine? There's going to be some other program, right? That's going to be like a Twitter game or something that ends up combining the graphics library with the Twitter API, right? Like, how would those two things, they would never talk to each other, right? So it's so hard for you to be able to say like, oh, they should be able to talk to each other to coordinate that. Sometimes that doesn't end up happening, especially when you're using these disparate libraries that aren't from the same producers or anything like that, aren't from the same companies or anything like that. And that's what ends up happening with a lot of software, right? Is that we just end up taking a bunch of different libraries, we combine them together, and then we end up producing some new awesome result, which again makes this really hard because A just ends up working on something that's completely different that B and C would never actually end up realizing. That they would be like, oh, there's this potential that there's this program out there called A that would end up using both B and C, and that would cause incompatibilities for us, right? That's just not something that's feasible. And so again, this kind of situation ends up leading to a lot of issues that, again, have been pretty much highlighted throughout the internet, right? So here was something else, right? Like I was mentioning, different languages just support this differently. Like I kind of mentioned to you all before, some make just extra copies of like in your computer of all the different libraries. And that's why sometimes like some of your Python directories or anything where you end up using something like Anaconda, that ends up being like gigabytes of files, right? Because what they do is they just end up, bringing out all the different potential versions that all of your libraries end up having. They just end up having those kind of in separate directories. And this also is the same thing with node modules in JavaScript. Because they're not necessarily sharing anything, they just end up being huge. And again, so that's what Python and JavaScript end up doing. Different languages do it differently. With Java, you can just end up renaming the library something else. And then in C++, you would just be able to do really anything. And C++ doesn't, obviously, right, if you aren't aware, right, just lets you kind of do anything and there's actually even arbitrary bugs that end up happening when you have different versions and stuff. So it does get quite exciting, right? For something like using a language like that. But again, having these things ends up being it does end up creating some difficulty. When we end up having these dependencies, because another thing that also ends up happening with this type of situation is we end up picking a potential very popular framework. And I know that, again, some of you have ended up saying like, well, I'm just using this framework over here that is used by tens of thousands of people, right? But again, that framework could end up using one library, right? If we go back to this network graph, this popular framework that we're talking about, Vue, can end up using this one library called source map.js, right? Or nano ID or even Pico colors, right? Where it's like this Pico colors, could just be being developed by someone. And so because we have this, we're saying, oh, we're using Vue.js, but because again, we have this network dependency, we now have this person in Pico colors that we're now depending our code on. And so if we think about that, right, that can end up leading to some very interesting situations like this comic shows here, right? Where we end up saying, here's what, here's our software, here's what we ended up kind of building all of our infrastructure on. And then again, it ends up saying that, we feel like it's going to end up working. But then there is this project, right, that some random person in Nebraska has been thanklessly maintaining since 2003. I'm like, so true, okay? You just have to realize that it's not as simple as just sort of saying, well, I only have to keep, that version of that one file. Because I was just talking to you about, the fact that there's the diamond dependency problems and everything like that. But, just even though that's the case, I would say that, depending on something is easier than us trying to rewrite the whole thing. And so I'm not necessarily discouraging you all from using dependencies, right? But it is one of these things that the book is saying like, hey, you want to pay special attention to this. And at a place like Google, right, where like, they have a lot of talent, they have a lot of people working, they try and tend to favor and saying, okay, can we just do this ourselves, right? Can we end up doing this on our own? And I'm going to end up just showing you a slide about that, yeah, gonna show you a slide about that. But again, different languages have these different promises. With something like C++, there's also different promises related to compatibility. Okay, and so with C++, there's this backwards compatibility with binaries. Okay, and so what that means is that if you end up having a DLL, right, or something like that, that you would end up, if you have an older DLL, you can end up plugging that into a new C++ project and it would end up working. Java has something very similar, right? That you would be able to just plug in a jar. It doesn't matter when that jar ended up being built, right? You can pretty much just use older Java with new code. Other languages like Go, what they end up doing is they promise what's called, instead of binary compatibility, okay, what they promise is source compatibility, okay? And so what that means is that if you have a library, you wouldn't necessarily be able to plug in the equivalent of like the jar or the DLL, but if you had the source code, right, you would just have to recompile it into a new kind of DLL for new versions. Okay, so if you have new versions, as long as you have the source, it will still work. It just means that you're going to need to recompile those libraries every time you kind of switch source versions or something like that. Otherwise you have to end up building the library again. And then there's other, there's other languages that, just have different promises as well, right? With like Python, I can't tell you the number of times that I ended up in Python, right, having the idea of like Python version 2 versus Python version 3, right? That those weren't always necessarily very compatible. It would end up breaking in those situations. And so then there's all this type of thing about like, okay, are we going to use Python version 2 or are we going to use Python version 3, in the projects? And for a while, I would say now it's pretty much all Python 3, but I would say maybe even 5-7 years ago, right, there was still this kind of like, oh, should we, do you want things to be stable or do we want things to be new? And there was a lot of limbo that was going on there. Again, they have kind of a different set of aims and rules, and that's fine. And even not only just even in languages, but also different libraries and frameworks kind of have different priorities when it comes to compatibility. For example, the Boost library, right? The Boost library is a C++ library, and it doesn't make any promises about compatibility, okay? So it actually, it kind of says, hey, we're not guaranteeing that any code that you write now will be compatible with new versions. So don't necessarily upgrade all the time. And what they end up doing, their kind of rationale for this is like, hey, we're an experimental library that's meant to kind of push the limits of things. So because we're this experimental library, compatibility is just not high on the list of our priorities. Like, we're trying to push the envelope here. And so, it's not that they're trying to actively change things, right? But they're just saying, like, if we find something better, if we find something that's going to work better for us, we're going to change the library and you're going to have to adapt. And so again, that's something that different libraries out there can end up doing. And so I think that this also comes back to the point that I was making initially about, dependency management in software engineering versus programming, right? You could certainly use something like the Boost library, right? And you would be able to just put that into a project and, it would be able to just immediately work, right? Or not immediately work, but it would, work with little effort. And again, for a programming project where you don't have to think about time, you don't have to think about time, you just need it to be working, that can end up working fine for you. In software engineering though, right, then you're going to have to start thinking about, well, the thing that the authors really make in this book, right, is they say, well, if this is going to be over time, you really have to think about that library. Who's going to maintain that library? Who's going to update that library if there's changes? Where is that going to end up coming from? And so again, that kind of takes more of that, like, hey, this is almost in that, like, hey, this is a liability, right? Rather than like, oh, this is the next greatest thing since sliced bread, right? It's like, if you're going to be putting this library in there, think about how that's going to end up affecting your project over time. And so what Google has actually done is they've kind of made a checklist, right, that you can end up kind of taking and saying, if you're going to end up thinking about using a dependency, this is a checklist of things that I would want you, that I would want you to kind of think about, right? Like, these are some things that you want to consider before importing something in. And so here they are, right? So they kind of ended up outlining this, and I thought this was a very good set of of questions to kind of ask yourself, right, before kind of importing any particular dependency, that's out there, right? And especially like, those third party ones. So first is, does the project have tests, right? Do those tests pass? A lot of the times you end up looking at a project, they have something here, like they have a little like, CI passing or failing, right? They'll have a little badge there. What's the reputation of the developers, right? They talked about how that shouldn't matter, but it does. What aims do they have stated about their compatibility? How popular the project is, again, because the more popular something is, that leads to better ideas of, for example, if it's more popular, there's a higher likelihood that it's going to be continued to be developed and maintained. Does the documentation detail, have details about the expected usage, right? To kind of really figure out what is it that they're banking on, and making sure that aligns with what you want to use it for. What's the frequency of the build breaking, right? So that would be something you can sometimes end up seeing this with like actions or something. And then also just like, some other questions that they had for specifically Google or working in a large organization was, who would end up doing an upgrade? How hard is it to make an upgrade? Can we end up implementing that functionality instead? Okay. And so Google kind of uses that question a lot, because what their idea is that they're saying, hey, this is a liability for us. If we can end up doing this in-house, we just end up having more control over, how this functions up happening. And so I think that's one of the reasons that you end up seeing that Google just has flavors of like everything out there, right? When you end up looking at their products or services, they're not necessarily, it doesn't feel like they end up leveraging a lot of things. Like even as they're kind of asking us about the different tools, and they're like showing us all the different tools that they've ended up creating over the years, right? Even in this book, right, everything's been very Google centric, where they're not using something that's already off the shelf, to do these things. They're really rolling and creating all of these tools themselves. And I think that's just evident too, as you end up looking at sort of even all of their software offerings, right? I mean, this is just a smidgen of things, but really what they just do is just bring it all in and develop it themselves, right? And this isn't really even all the stuff that they've had to deprecate or anything like that, but there's just lots of ideas here where some of these have been done by competitors, right? With a lot of these different products that you see here, other folks have ended up trying to do these things, right? But they just ended up saying, well, rather than using that, we're going to end up doing our own. And I think that's partly just because, again, I don't think that it's something that all companies end up doing. And again, I think that's why they talk about it so much. I mean, they're in a kind of separate situation, right? But I think one of the things that they're saying is, if it's something that's really simple, that it's a library that maybe takes like 30 minutes, I think Google would end up saying, well, we're just going to develop this, right? Because it's a lot easier for us to just make. And then again, we have full control over it than to kind of depend on something else, because again, that becomes tricky. So, just to kind of add a little bit more to that checklist about whether or not to import, there are a couple of other things that they want you to do. So they want to make sure that OSS library, for Google, right? If you want to be able to add some type of third-party library to the mono repo, right? They essentially have a checklist, and they just say, make sure that open source library, whatever you want, builds with our build system at Google, has no version that's already in the system in our mono repo already, and has 2 engineers as owners of that library, to have that be maintainers. And they said, even though this is a process and they're kind of proud of this process, it still doesn't end up being enough. And the story that they gave about this, I think, ends up being very, very pertinent or real, right? They, not the names and stuff, but they just said, Alice and Bob, right? Alice and Bob wanted to use this open source library. And so they ended up signing up to be the code owners for it. And then it turns out that 2 or 3 years later, that open source library has a critical bug that needs to be patched. And so for that to end up happening, they end up wanting to ping Alice and Bob, but it turns out that Bob is now in a management role and Alice is no longer at the company. And they said that that's all too often what ends up happening in this case, right? Where it's like, you can end up having these code owners there, but then they can end up just not having looked at code for a few years, right? A lot of these kind of dependencies that happen in some of these critical updates, they happen so infrequently that, and there's so much time that ends up spending between these, that when someone initially was like, hey, this is a good idea, I'm going to go ahead and sign myself up to be a code owner for this library that I don't have to look at every day, right? It's not that they're actually doing active development like the other code owners would end up doing. It's just that they're saying, yeah, I want to use this library, I'll vouch for it, right? I'll vouch for it, let's use it. And just 2 years later on, that could end up going away, right? There's not that necessarily that commitment, which again ends up making using third-party libraries pretty tough. And so that's again something that Google is kind of trying to talk to you, or essentially discussing in this Flamingo book. Another thing that they wanted to discuss was just, if dependency management is so hard, what are some of the different approaches that we can take? And so they ended up outlining a few different ones. And so I wanted to kind of discuss those with you here. One of the first ones is just this idea, right? The first approach that they talked about was to say, you know what, we're going to just end up assuming that, nothing changes. And, in that type of situation, that just ends up meaning that nothing ends up happening, right? And this is just simple because then no decisions need to be made on what versions there are. And, there's not necessarily any versions. It's just whatever version is there is what we have. Okay. So that's kind of one approach that you can do, is just to say, I'm not ever, changing anything. We're not changing any versions or anything. We're just always going to stick to the same one. I think it's an easy, simple kind of approach that you can take. Another one is to use what's called this bundled distribution model. So there are distributors out there, like OSS distributors or something, that what they'll do is they'll end up saying, hey, we found a set of OSS libraries, like open source libraries, that work really well together. So what we're going to do is we're going to kind of create a bundle, almost like the Humble bundle, right? Where we're just going to package all of these libraries that we end up knowing work really well together. We're going to put them as one thing that you end up downloading or using. And so in that way, they kind of end up spending a little bit more time to kind of make sure that those things are operating correctly, which again ends up being nice, because then we don't have to make sure that we're getting this version here, we're getting this version here. We could just say we're getting this particular bundle, which it will already be a set of libraries that someone else has kind of worked and made sure that they end up working well together. There is this other option, or this other approach that they end up talking about, which is called live at head. Okay. Yeah, so what this is that for live at head is just that they always end up depending on the latest of everything. Okay, so rather than you kind of sticking to a particular version, or using the bundles, you're saying, you know what, I'm going to just grab the latest versions of everything. Okay, and that responsibility ends up happening a lot with the developers of the API, right? Or the people that are kind of responsible for building the dependency. What they'll end up doing is they'll have the dependency folks, if they do want to kind of upgrade things, or they have to make changes, anytime that they end up making changes, what they do is that they end up setting up the build system that Google has, right? And this is something specifically for Google. What they do is that, hey, there's this library that we all depend on. Let me go ahead and make changes to the library, right? This like logging library or something that's that's used by everyone. Let me make the changes, and now because it's in the same repo, I'm just going to go ahead and run tests on all the rest of the code to see if my library with my new changes ends up breaking everyone else's code. Okay, so again, a very interesting kind of way of being able to do this, of saying, hey, you know what, there's changes here. I want to push these changes. I want to make a new version of this. Before I end up kind of committing those changes, I'm going to go ahead and see what exactly breaks by me kind of building it and packaging it and kind of running the test there. Okay, I'm going to see what would end up breaking in that situation. So those are kind of the three different versions, three different approaches that they talked about, as well as sort of this semantic versioning, which I ended up putting as its own section, just because it is something that it ends up being talked about a lot. Okay, so semantic versioning, let me go ahead and just, if you're not aware of that, let me go ahead and talk to you about that, what that is. So you all have seen semantic version already. You've ended up seeing kind of files or libraries that have a kind of numbering system like this, that end up having these three numbers separated by two dots. Each of those numbers ends up being the major version versus the minor version versus the patch, right? What normally is expected is that, minor change would end up being particularly maybe some features that you're adding, but you're not necessarily breaking anything. right? The patch would be just that you're fixing bugs. And then this major version would be potentially, deal breakers kind of thing. Things that would end up breaking your, that would end up breaking your build if you ended up, switching to a new version, right? So if, let's say again, that you had a logger, right? And you had a logger version 2.0.1, right? It means that once you switch to 3.0.1, things would change. And so again, I think with like Python, Python has this issue, right? Where, I think that that's a good place to start, right? If we had Python 2, we would have 2.6, 2.7, 2.8, right? And then at a certain point, it's like, okay, we're stopping with that. We're going to now go to 3. And then, again, code ended up breaking. And there's probably just, again, lots of different versions as we're going around in terms of what the different libraries are. And I would say I've seen a lot of libraries that have sort of that versioning number. I would say a lot of them end up ascribing to that. And one of the things that we end up doing with semantic versioning is that we can end up providing rules in our own software when we end up using a library to say, oh, this library is going to require, this particular library, this other library, and we need to make sure that we get a version that's greater than 1.5. Okay, so that is something that we would be able to start putting into our build tools. And then what ends up happening is because we now have to we have all these different requirements, right, with each of these different libraries and stuff. And we're essentially generating a network of all of these libraries and dependencies. We end up using SAT solvers to find, some set of dependencies that ends up working. Okay, that does end up leading us to dependency hell, and I'll give you a couple of different versions of what that ends up looking like in a bit. Okay, but a SAT solver is really it's an NP problem, right? And it's onerous. It ends up being onerous to try and find something that works. Okay, and it's just hard because developers don't and the way that it ends up working is that it just ends up kind of looking for dependencies that are going to work, right? It tries to satisfy all of the rules so that you can end up getting essentially a set of versions that will work with everyone. And with semantic versioning, one of the other big issues, right, is that it's up to the developers to adhere to these standards that we're doing of using major, minor, patch, right? It's really hard for us to be able to prove compatibility, right? Especially with something like Hiram's law when we start making changes, right? Because we end up using the software in ways that maybe are not expected. And so again, what we would end up, if we use it in ways that aren't expected and that library developer ends up changing things, right, to, help with whatever things they have to do, that could potentially cause our software to break. So, again, that doesn't end up making things very fun for us. This idea of semantic versioning, it just becomes really hard, again, because the developers just don't have a great way to know that that it won't break. That really what this versioning that we have here is really just an estimate. It's just an estimate as to what we feel or what the developers feel are actually the different versions that are out there. Okay? So in addition to just being hard, there are a couple of other drawbacks that we have. So one thing is that, you can over-constrain libraries. So that would mean saying something like, I'm only going to use 1.135 version of this library. And over-constraining is bad because then you won't be able to update anything after it finds a solution, right? If you end up saying this is the only thing that works, you want to try and update, that's going to be an issue. Over-promising, or another issue that we can have is that we can end up over-promising libraries. And with over-promising, right, rather than kind of constraining something so tightly here, we're saying things like use any version, right? Like we don't care what's going on, just use any version, go ahead and do that. And over-promising is bad because sometimes what can lead there is that we can end up just introducing breaking changes, right? It ended up finding the solver, right, might end up finding a set of libraries that it thinks ends up working, but we end up finding that doesn't end up working. That causes our system to crash, and then that could end up being just annoying. Okay. Same thing with this, right? We end up saying, okay, we're going to end up doing version 1.1.15. If we're doing something like this, right? If we're saying something like version 1.1.15, if we have to include that patch number, again, that's kind of an indication that maybe our API developers, right? Or maybe the library folks, the library maintainers aren't holding up their end of the bargain in terms of saying like, hey, you need to make sure you're above this patch, right? I think that just makes things much more difficult for you to be able to follow. Okay. And again, that the solver is just trying to find what's the combination of library versions that I can end up using. Okay. I do want to tell you about a couple more things about semantic versioning, though. First is just that, again, the libraries and the projects, right, like we had talked about, was just that they have different motivations around compatibility. And so with that, I think that the Flamingo book authors ended up saying, any project that's out there really should outline what the intent is around compatibility, around usage, and around breaking changes. And I ended up mentioning Go and Closure here because they have a policy of when they end up going into major versions, what they're going to do is they ended up talking about repackaging and renaming everything because they're not guaranteeing backward compatibility. And so what that's doing is that's forcing people to use like new names and such, new package names and stuff, just because it's not that, maybe what was there once is not there anymore. And again, I think this is a valid way to be able to do things. Obviously, that makes it a pain for the people that are working on it, but it kind of really highlights this idea for those folks that are using those systems to say something like, hey, we upgraded. You should know that that you're upgrading. So you should actually go into your code and change all of these things. So that way you're aware of it. Otherwise, if we end up kind of keeping the same compatibility from before, even though there's new functionality there, we could end up kind of introducing more insidious bugs, right? And more like sneaky bugs of what's going on. By kind of forcing folks and saying, hey, look, we're updating to a new version. You're not going to be able to call this function anymore. You now have to call this one. It seriously makes them have to think about, okay, is this doing, serving my needs, and should I end up following this rather than just like sort of like update. Let me go ahead and get the latest version. One other thing that the authors ended up providing was a different approach, or sort of a different strategy for kind of coming up with version numbers and how to be able to deal with dependencies. And so that process is called the minimum version selection. And what they were doing there is they were saying, look, if you have something like 1.1.3, okay, and someone else wants you to do, I don't know, version 2 or something like that, like they want you to do that same version of that file, what you would end up doing is you would end up just saying, well, I need to pick a new version of 1.1.3. Let me go ahead and check to see if 1.1.4 is available and can be checked in and run tests, right? We end up running tests by kind of adding in the 1.1.4 to our library, see if that ends up working. If that does, this is as far as we go. We don't go any more with this. And the reason that we would want to do this minimum version of not going to say the latest thing, but just kind of doing the version that's closest to what we're looking for, is just that it does end up leading to this idea of high fidelity builds, which just means that whatever we ended up creating in 1.1.3, it kind of gives us more hope that, oh, we didn't end up kind of creating too many breaking changes in there. We have 1.1.4. It's not too much extra edits. I think that ends up being okay for you to be able to do that migration. Okay. And so really what they want you to do is just move a little bit and then run tests. And then if the test pass, great, that's your new version. If they failed a lot, then you would end up moving a little bit again and then running those tests again. Okay. And here, this is again, not really necessarily trusting of the semantic versions, right? That, you have to realize that semantic versions are just a version that ends up being done by the developer, right? They're the ones that are going to be able to decide whether it's a patch, whether it's a minor or major version of something. And so I think then from that standpoint, we have to be careful about that. All right. And so let me go ahead and just, keep going. Because while I have been kind of showing you some different versions of it and talking about the cons, it is popular. It is something that, most folks end up using. And so, the authors end up kind of saying, look, it is popular. We know that this is here. So here are some ways that we think that semantic versioning can work. So they ended up just saying, hey, semantic versioning can work if, right, your dependency folks are truthful and accurate, right? If they end up providing the truth, because again, we can't test this, right? If someone ends up saying 2.2.1 and then they start releasing 2.3.1, right? We can't necessarily know, hey, this is the correct versioning or not. We just end up having some idea. So they're saying that semantic versioning can work if the dependency folks are truthful, right, and accurate, If you're using the dependency as intended, right, you're not doing something unusual, which would end up kind of going into that hierarms thing. And then just if the dependencies are fine-grained, right, that we end up kind of saying this is the type of version that we end up wanting. That if we end up doing all those things, semantic versioning can work. But it is hard to be able to hold these all when you start going in like building at scale. Okay, that it's a much harder thing to be able to do. And so they, the authors of the book, right, the Flamingo book, kind of ended up, really saying, hey, if we want this to work, if you want to be able to kind of continue working with semantic versioning, here's some things that we want that we would like you to do. Okay, and so let me go ahead and just move over that slide there. And so here, what they're saying is, so they're saying, okay, if we want to make semantic versioning work, let's go ahead and do the following things. Okay, they're kind of mentioning that all dependencies should have unit tests, right? That the network for the dependency should end up being understood, right? So that's potentially looking at that dependency graph, understanding all the dependencies that you have, having more access to compute resources for more testing. Again, if you end up doing things like if you're the library person and you are testing this thing, you're about to push a new version, you want to be able to do some of that testing across as many projects as possible to kind of make sure that you're getting, some better idea as to, yes, this is correct, right? I'm doing a good job with this. I'm not breaking everyone else's code as I'm doing this development. I think also that I thought that it was interesting that they were talking about adding some type of history or reputation in calculations for so that they would end up doing some calculations for, maintaining a reputation. And they would also have a history of like broken builds. That I thought that ended up being very interesting, right? So that way you can kind of see how flaky is it or something like that. But really what they kind of ended up ending with and saying, well, you know what? All of these features are really things that, again, look very similar to what we ended up doing at Google with the Live at Head, which is, again, where we have some library, let's say A, that if we want it to kind of work in this and we have this library, we want to make sure that library A has all of the resources to be able to test their library changes across an entire repo, okay? Across an entire repository. And so they're saying, well, if we have all of these rules, this is really pretty much like what we were doing before with Live at Head, where we're just trying to keep everything to be the latest as possible. So I think finally one of the things that they kind of brushed on was this idea of like releasing software, right? That I think we're all enamored with this in a way where we're just like, well, I'm just going to go ahead and publish this and make this open source and make this public and, just kind of have it be public and say, okay, I'm going to give this as my gift to the world, right? This beautiful code. And I'm guilty of this as well, right? And I think one of the things that the authors are saying, especially again, if you're doing it representing a company, I think it makes it even more pertinent where they're like, hey, you want to think twice about doing this. You don't just want to kind of like put something out there. And I think a lot of companies are guilty of this, right? Even Google, they mentioned, a couple of missteps that they had with the flags with the compiler flags for C++. But really, I think what they said is if you're thinking about releasing software, you really want to consider the risk, benefits, and costs, right, to your users. So you have to think about all of those. It can really be awful, right, if it's not maintained or implemented poorly. That could be something because then people end up being like, well, why did you do it this way, right? And then they want to kind of make changes. And I think it also hurts your reputation, right? That if you're doing this as sort of a if you're doing this for another, if you're part of a company and that company is releasing the open source software, that if it's implemented poorly, that really has a knock on your reputation. They really also come back to this idea that some of you are very well aware of, which is just the idea of community over code for open source projects, right? That kind of the people part is still hugely important. And there was a couple of lectures that you all had, even the lecture, for example, about getting involved in open source projects that really kind of talked about this, the one that was on Vimeo. They were just like, hey, community is so important in terms of trying to get something off the ground. And really, again, too, to have a plan to support this for the long term, right? So how would that end up looking like? And so those are all things that you would want to kind of make sure that you are thinking about before you just kind of try and just throw your code over the wall or something like that and just say, okay, it's there, I've released it, that there is these extra things that you have to think about. So kind of, as a chapter summary, here's what this chapter was really talking about, right? Is that they wanted to kind of have you think of putting stuff into source control over like having to work with the dependency manager to be able to find versions of like external libraries and stuff. They're like, if you can check it in a source controlled, that's even better. Or if you can kind of have some development over it, that's good. And the fact that adding a dependency isn't free, right? There are costs. There's maintenance that's associated with that, right? We always tend to think, oh, open source is free. There's nothing wrong with it, but there is an actual cost. That dependencies could end up being a contract, right? To kind of say, when I'm doing, if I have this library, this is what I'm going to end up providing. The semantic versioning, right, really is, I've been mentioning, is just an estimate, right, about how risky developers are going to think the changes are. That's really what semantic versioning is, right? If they're like, oh yeah, we ended up making these changes, it's not too bad, we're not going to necessarily break. They're the ones that are making that estimate. They do argue that having more tests and particularly continuous integration, which we'll talk about in our next lecture, can really help just give a better estimate as to, how risky those changes really are. Okay, because if it starts breaking everything, then that kind of gives you a good indication. And then also just that releasing your code to the wild can really become just a challenge for your compatibility, especially when you're doing things at scale, right? That if you're kind of doing things at scale, that you want to kind of second guess yourself before you end up, just releasing stuff into the wild. And so that's pretty much it with dependencies, which is actually the larger chapter out of the two. But let me go ahead and just move on and talk to you about our other chapter, which was large-scale changes. Okay, so large-scale changes, one of the questions to just ask here is like, a large-scale change is just like how many files can you reliably update in a single commit, right? I mean, once it kind of goes outside of that, like that would end up being considered a large-scale change. And as a code base grows, it does become harder to make large-scale changes. You do have to kind of reason about large-scale changes differently. And so again, this chapter was kind of devoted to, hey, large-scale changes happen. We need to think about them. Here's how we end up doing them at Google. And so I guess the first question would just end up being like, again, what is a large-scale change? And I thought the authors ended up kind of defining this pretty well, so I just ended up attaching this quote here, where it was just a large-scale change is just any set of changes that are logically related but cannot practically be submitted as a single atomic unit. I think the way to kind of think about it is that you have so many files that you have merge conflicts, right? When you have merge conflicts, you can't just make it one commit, right? You're going to have to kind of do some different, you're going to have to do some different magic trickery to be able to do that. And so, that's normally what ends up happening. However, if you were to try and, say you had 10,000 files or something, that could also end up triggering a large scale change. And so that is essentially what a large scale change is. Let's go ahead and just talk really quickly about why. Why would you want to do a large scale change? A lot of the large scale changes have near zero functionality, but really we want to be able to, and so the reason that we want to have those large scale changes are normally for, clarity, optimization, and like future compatibility. Okay. So for clarity, right, we would want to do a large scale change to kind of clean up code issues, right? Found via, our static analysis tools. We'd want to be able to replace some deprecated code use, right? Could also think about having compiler upgrades or just kind of migrating to a completely new system, toolchain, whatever it is there, that you would have to think about, making some of those different changes. And so then, we've kind of talked about what a large scale change is, why we have them, right? The next is like, who should do these? And Google has a very specific way or a very specific answer for who they end up feeling that should end up doing these changes. And they really talk about sort of having an infrastructure team. They say infrastructure teams, which would just be, specialized teams that are just dealing with infrastructure stuff. They have the knowledge and experience kind of fixing these particular large-scale changes, which I'll just refer to as LSCs, right? They do have that knowledge of experience of just like fixing and working with large-scale changes. They typically also have a motivation to kind of move people off of old systems. If they're having to provide a lot of support there, they would end up doing that. And then also it just requires that they have some type of automation. Okay. And so then one question that you may think about is like, well, why not, why have these like other specialized? So if we're thinking about the, group and stuff, we have kind of this infrastructure folks over here, and then we have the developers, right, or the software engineers, over here, right? And so one question that you might have is to say, well, why not have code owners, right? Like, why not have the folks that own those changes, make some of these large scale changes? Why have these specialized infrastructure teams do it? Why can't we just have the code owners? Well, code owners don't necessarily have motivation to change. They don't necessarily have the motivation to change, any of the files, just because it's almost like a pet of theirs, right? They can end up being like, you know what, we're fine with using the code as is. We don't necessarily need to make any particular changes. That code is working fine for us. Why do we have to change this, right? And so there's a little bit more of this like, hey, it's working, if it isn't broke, why fix it kind of thing. That I think you get a little bit more pushback from code owners from that standpoint, right? They have something that's working. You're potentially going to produce more bugs. Why are we doing this type of thing? That's the other thing. And then the other one is just the idea of that code owners start to think of their changes and commits also as being like their pets, right? In terms of like really trying to keep them intact and everything. And this can end up happening with something like a merge conflict, where if you're having to deal with merge conflicts because you're doing these large scale changes, sometimes just existing codes ends up being thrown out, right? Or if there's two duplicates of it, it's like one of those is going to end up being thrown out. And I think with code owners, it ends up being a lot harder to say like, oh, like I'm going to keep this one, right? Or I don't want to end up making these changes. You start to kind of have these extra accommodations, for this code, to try and say like, oh, maybe we need to combine the two so that way we're not hurting anyone's feelings or something like that. Infrastructure has the experience, they have the knowledge of doing these changes, so they say, you know what, let's go ahead and us do it ourselves, right? If we end up losing some particular change, there's no hard feeling or anything like that. We're trying our best to not necessarily rate a pet, but just like herd cattle, which was the example that they gave. They said, we're going to just herd cattle and we're going to try and move all of these changes from here to this other one, right? If there's a change in, if there's a rejected change or something like that ends up happening because of that, I'm not worried about that. Or if we have to kind of change one thing, that's fine in this instance of trying to move everything along that way. And so while making changes, right, that is the goal, right? There's also just barriers to making a single atomic change anyways, right? And so what are those barriers? There are some reasons why we can't just make one single atomic change, and we have to kind of split this up. One of the reasons is because we have thousands of files sometimes, right? In a large scale change, we have to modify thousands of files at once. So there is just technical limitations for that, okay? If we have merge conflicts, we can't necessarily just make one change that ends up fixing everything, right? We can't just make a single commit there. You also have things like haunted graveyards, and haunted graveyards is great. I thought it was a great kind of terminology when I heard about it. Haunted graveyard is just a system that's just so ancient, obtuse, complex that just no one enters, right? They're just like, look, that part's working. I'm not touching that part of the code with, I'm not even touching that part of the code with a 10-foot pole, right? You're just staying away from it as far as possible. They decided to use this haunted graveyard analogy. I thought it was great. The fact that you would end up having code that's using varied tool chains, right? Different libraries, sort of like lots of different sort of a variety of sort of continuous integration tools and all the sorts, like all the different tools that are out there in libraries. If they're using that also makes it hard for us to be able to do a single commit. The fact that you want to be able to test failures after changes as well, right? That if you're making an atomic change, you want to be able to test it, to kind of have it. And then the last one that it makes it hard for us to do is also that we're, or at least in Google, they're using the code review. That any type of large scale change is still going to end up having some type of code review in there. So it wouldn't necessarily just be this atomic thing. Okay. One other thing too about the test failures after changes, this becomes tricky because, let's say that you do end up changing something. Yeah. Let's say that you do end up trying to change or like you end up running your tests, right? For a large scale change, and then you end up finding out that it breaks, right? Normally, when in normal circumstances, if you have a commit, you kind of run the unit tests afterwards. There's just a small amount of change. You kind of know exactly where the code is changing, because it was like it was working a minute ago, now it's not. What's the last thing that changed? I can end up focusing my efforts on finding that bug. In a large-scale change scenario, you're talking about having 10,000 lines of code, right? Potentially 10,000 lines of code. That makes it so much harder for you to be able to find that bug, right? I mean, that's what ends up happening in that situation. So again, that makes it really hard in that type of situation. And the other thing that I forgot to mention is one way, I did kind of mention the haunted graveyards, but one way that we can end up getting away from haunted graveyards is just us implementing more testing, so that when we make a change, we end up feeling confident that that change is going to end up working. Because again, we've ended up adding more tests, making sure that we feel confident about our tests, and kind of stress testing and making sure that things are working. Again, so that when we make the changes, and we know that the tests still pass, we feel confident that it's like, okay, yeah, this isn't necessarily a haunted graveyard anymore because I can end up changing the code. Large scale changes can be tricky. And so Google ended up providing one type of large scale change. They ended up in the book talking about the change that they had to make in C++ to go from scoped pointer to this unique pointer, which is part of the standard library. And so they ended up saying, you know what, in C++, in version 11, they introduced kind of a better pointer structure, which was the standard unique pointer. So we're going to end up using this one instead. And so what Google ended up needing to do was they had to change, again, from scoped pointer to unique pointer. I wanted to bring up this slide just because, again, as I was reading this and they kind of talked about this as a case study, which is just an example, right? That they said that 500,000 references to scope, that there was 500,000 references to scoped pointer across millions of source files, right? And this line ended up being just like, wow, just the sheer, large scale change ended up being awesome here. So they just said, at the height of the migration process, we were consistently generating, testing, and committing more than 700 independent changes, touching more than 1,500 per day. Right? Like that is a lot of change, right? To have to kind of deal with. And again, that makes it harder, all the more so why I think that their ideas of saying like, yeah, we need a separate team that kind of has the experience to be able to make so many changes in a day really comes to fruition, right? That they definitely need that team to kind of handle those things rather than for us to just say, oh yeah, we're going to end up making all those changes ourselves. And so, they are really saying, in a way, the large scale changes can be scary. Okay. And so one way for us to be able to reduce that scariness is to have a process that, whenever we have large scale change, have a process for when we say, hey, we want to make this large scale change, go ahead and before you start working on that change, check to make sure that it's worth it. Because there could be certain situations where you end up saying, you know what, I think it's okay for us to end up having this variable, that doesn't necessarily follow this case or whatever it is, right? That, there could be these situations where you could say, yeah, that like having that is not necessarily worth it. It's not a priority for us right now. That's one way. If we have that process, that's something that would end up being able to reduce the scariness of it. They also talked about training code owners about the fact that large scale changes are important to Google, right? In particular, and for scaling software. So really it's kind of training them to say, hey, we need to do these large scale changes. They're important to us. And then also training them to kind of trust infrastructure teams. And they ended up kind of coming up with a rule that I thought was interesting, was just if you have to make more than 500 edits, make sure that you end up looking or developing a tool for it. That if you have to do 500 manual edits, that's kind of the limit of what they would do. I think that's pretty high. But again, maybe there's sort of just differences in ways that they would be able to do that as well. But again, this is part of their process, and this is what they end up doing at the company. So the last kind of thing that this chapter ended up talking about was just this idea of, if you want to make a large scale change, what's the process that you would end up going through? And so they ended up outlining 4 steps about how you end up making a large scale change at Google. Okay, so the 4 steps roughly are to have this authorization, kind of do the change creation, then do the shard management, and then the cleanup. And I'll talk to you about shard management, but essentially what it's saying is, because we ended up talking about how the commits are so large, right? The commits are so large that it can't just be a single commit, or the number of changes that we need to make are so large, we can't be just one specific commit. What we end up doing with sharding is we end up saying, well, let's go ahead and split that large scale change into smaller files, smaller subset of files that we then go ahead and commit. Okay. And so then there's this idea of like, okay, if we're doing this in these smaller batches, right? We want to make sure that as we're doing those smaller batches, we don't necessarily break anything. And so how do we end up doing that effectively? And so again, they're really just talking about the process here about how this ends up happening. So I'm going to go through each one of those steps in just a little bit more detail. Okay, so the first step, which was authorization, really what they do there is they just have a form just asking, why do we need the change? What's the impact on the code base? And then just sort of like I ended up saying, explain it to me like on 5, but really trying to just think about how would you end up explaining this to the other engineer? Who's the code owner and who doesn't really want these changes to end up happening. Like what's sort of the rationale there? How are you going to end up convincing them? So that's what you end up doing from that standpoint. Then once you end up submitting that form ends up being forwarded to a large scale change committee, which they said was about 12 people that were on an email list. That committee just gives feedback on how to move forward, whether it's feasible, and then they, typically approve it. And they said that most of the time approvals are pretty much a done deal. And they've ended up finding out that process doesn't necessarily have too many hiccups, for their intended usage. So after authorization, we now have this idea of change creation, where what you end up doing with change creation is you actually make the edits, right? You make the edits to the code so that you end up incorporating those changes that you wanted to make. And then the other thing that I thought was interesting is that Google made an extra point here in the chapter, or at least the authors, of saying, look, they optimize for human readability. We have to make sure that that's a part of what we're doing here. Okay, so after doing the edits, you now end up having the sharding and submitting, right? Where you're kind of just bundling some of the files that have all the changes together and you're making that one commit, right? So rather than you saying, okay, I'm going to try and commit all 10,000 files, you're saying, hey, these 3 files are doing the same thing. They're doing enough of it. Let's go ahead and put that into one commit. Okay. So what it does is, again, takes from a formal standpoint, we're taking the changes, we're splitting them up into those shards, and then each shard can end up being committed atomically. And what we do is we start testing the changes as it goes along. They did end up having this interesting testing pattern where what they were saying is we every time that we're doing one of these changes, right, where we're like changing, a few files at a time or whatever it is, right? We don't necessarily need to run the entire suite of tests. We just need to run the suite of tests for the code that we actually ended up changing. And so they ended up having a different sort of schematic where they were like, we have millions of tests, but we're only going to, these shards, we're only going to run on like 1,000 tests, where some of them are randomly selected through to make sure that everything ends up working. And you start doing that testing as you're going along, okay? So you're not running all the tests because not all the parts of the code are there. What you are looking for, though, as well as you're going through, is you're looking for flaky tests. You're kind of determining, hey, has this test been flaky before? Because if it has and things stop, then you may perhaps continue, or, after fixing that test or not paying attention to it. There was a couple of times I was surprised, too, in the book that they were like, oh yeah, we have flaky tests, we just ignore them. I'm like, okay, yeah, I guess that's one way of doing it. So after you kind of do some of the testing, right, make sure that everything's functional, you then end up mailing the reviewers, okay? You mail the reviewers, say, hey, here's my code, right? Now, I've done this large scale change, can you end up taking a look at it? And then we end up having a code review. And that code review, again, is meant for this global infrastructure large-scale change reviewer. It's not necessarily sent to the local code owners. Again, because the local code owners may not have as good of an understanding of what's going on, as much as the large-scale change folks. So after doing the test stuff, we then end up moving on to cleaning up, which cleaning up ends up being a very, simple, set of steps here. What we end up doing is we just end up figuring out, right, some way to prevent whatever large-scale change we ended up having, right, we figure out a way to prevent that from happening again. So that could either come in the case of like additional unit tests, maybe we have some custom style rules, or etc. But really all this is saying is like, if you just ended up spending again, you had this large scale change that was like 10,000 files where it's like, hey, you can't use applet anymore, for example, from Java. And what you want to do is, if you ended up just removing all the references to applet and you ended up kind of migrating everyone to, say, Swing, what you want to do is you want to have some way of being able to prevent anyone else from coming in and saying, oh, I'm going to go ahead and add this dependency to applet again, right? We don't necessarily want something like that to occur. And so we want to be able to prevent it, especially if we end up taking a long time doing that stuff. And, that's pretty much it. I mean, if I was to try and give you a summary of what this chapter would end up looking like, it's just that having a process for change, can really allow you to make large scale changes. And having infrastructure staff dedicated to large scale changes really helps more than doing it sort of the traditional way where we have the code owners and stuff going in there. And so again, thank you for kind of dealing with me and putting up with me for this thing. In terms of what you would end up being able to provide, you can just end up giving me kind of any feedback that you all want as you're going through. If you noticed anything about me, right? If you have any questions, feel free to reach out and put that into those reflections. But again, that'll be the only lecture that we end up doing this week. The rest of the time I'm going to end up using to try and get some feedback from you all. But I think the thing that I'm going to end up doing right now that it's past 3 o'clock, is I need some sleep. If you all were not noticing. So I'm going to go ahead and try and get some sleep as soon as I end up releasing this. Have a good one, and I will talk to all of you. I will hopefully talk to all of you soon. Thanks.